Good morning, sir.
Good morning.
Good morning.
Good morning. So good morning everyone. Already we have started Z transform. That is our last topic. Already we had some idea because from our last class. So today we will be discussing here properties of ROC. So before starting this properties of ROC, we will take few uh, examples. Okay, for better understand. So already we know Xn is the signal sequence here. Z transform is Xz, that is written as n is equal to minus infinity to plus infinity x of n z to the power minus n. So we know these things little. Now in our last class we got this relation. Okay, what is that? Suppose we are having x1n is the signal sequence that is equal to a to the power n un and we got the z transform of this signal is some kind of that 1 by 1 minus a z inverse. And for the second signal x to n minus e to the power n u of minus n minus 1, for this sequence we got the z transform as 1 upon 1 minus a z inverse. So both the cases we got the same z transform. Numerical values are same, but where is the difference? Difference is in ROC. The first case we got ROC mod z greater than a. Mod z means r. R means the radius of the circle. So in this case mod z greater than a. So the ROC should be outside the circle of radius greater than a. But in this case, just opposite, it is the ROC will be within the circle of radius less than a. So that is the case, and pictorial view also I have discussed in our just last case. So that's two cases we got. Okay. Now thing is that so in this case DTFT, if you want to find out DTFT of which signal, which sequence, for this a to the power n even, the first case one. You people know that if R is equal to 1, so that Z transform automatically converted into DTFT. So if you take the Z transform with unit circle, when radius of the circle if it is unit, so there is no difference between DTFT and the Z transform. Okay. So if it is A and if it is R is equal to 1, so DTFT should be in this region, the dotted circle, because R is 1. So DTFT of a to the power u of n, we got 1 by 1 minus A e to the power minus j omega. Because you will know that the value of Z is R, you will know that the value is R e to the power minus j omega. So value of R is, if you put value is 1, so we got the same expression DTFT a to the power n even and the Z transform of a to the power n even. Keeping in mind here R should be 1. Okay, if you put the value of Z here and you put R is equal to 1, in that case this expression and this DTFT both are having the same, because DTFT is calculated with the unit circle. So that is not new thing, already we have discussed. Now, if you take, so you remember these two transform for x1n a to the power n un, that is for right sided sequence, and x2n minus a to the power n u of minus n minus 1, that is for left sided sequence. So these two properties, these two conclusions you have to remember. Along with the third one, suppose you have the sequence un, that is unit step function. Okay, you have only un, so that is unit step function. Now if you consider here a to the power n u of n x1n, so now if you take a is equal to 1, so that means this x1n is nothing but un. So in this expression, if you put a is equal to 1, you will get the Z transform of un. I am repeating it once again. My question is, you have to find out Z transform of un. Okay, Z transform of un. The un, what is un? Unit step function. Now, if you come back to this expression, x1n is equal to a to the power n un. This is the expression. Now, if you think a is equal to 1, that is mod z greater than 1 or r greater than 1. In that, 1 means radius 1. So it's simply u of n. Okay, so that means you get this expression xn is equal to un. Now what should be the z transform? So now put value a here 1. So 1 by 1 minus z inverse हो जाएगा. 1 by 1 minus z inverse हो जाएगा. ROC should be r greater than 1 or mod z greater than 1. So that I have written here. So the z transform of un should be 1 by 1 minus z inverse, and ROC should be mod z, or you can say other word r greater than 1. Okay, so that is the case. So we got the z transform of un. Okay, जैसे तुम्हारा लेप्लास ट्रांसफॉर्मेशन में z ट्रांसफॉर्म लेप्लास ट्रांसफॉर्मेशन ऑफ यूनिट स्टेप फंक्शन क्या था 1 by s था, डेलन के लिए था 1. So that is here the Z transform of unit step function, and these are standard waveform sequence. So that's why I am telling you this is x1 and x2n, and this un, basically these are the standard waveform. We can't say here waveform, it's a sequence. So here now the fourth sequence is xn is equal to del n. You know that del n, what is del n? Del n is unit impulse response. We know that. So now find out the z transform of this unit impulse response. Okay. So what is the formula? N is equal to minus n into plus infinity del n z to the power minus n. Okay. And you know that the property of unit impulse function, if the function is multiplied with the delta function, then that function will exist only at the origin. Other than zero value, it will never exist. So in this summation case also, n is equal to minus n plus n, range is whole range, but this xn will exist only at n is equal to 0, that is origin. See. So x of n is equal to n is equal to 0. So that's why what should be the function here? Xn means z to the power minus something like that. So this z to the power minus n will exist at n is equal to 0. So if you put the value of n is 0 here, so that is z to the power 0 means 1. So xn is equal to del n, and if we got the z transform, that is also unity, like your Fourier transform or Laplace transform. Okay, the value is unity. So what should be ROC? As it is a constant. Okay, it's a constant independent of Z. Okay, so that means we can say that entire Z plane. That means entire Z plane is the ROC. Okay, so these are the four basic sequences you have to remember always for doing Z transformation. Okay. Now I am taking one more example for better understanding, because that was del n. Now we'll take one shifted delta function. You people know that del n plus 1 or del n minus 1. So now here, you people know that shifted means del n minus 1. So it's something like that. The delta function is shifted to plus 1 position. That is del n minus 1. If it is del n plus 1, it should be at n is equal to minus 1. That is del n plus 1. You know that all these things very well. I'm not, I have no, I don't have any doubt about that. So x of n is equal to del n minus 1. So now put it in the formula. X of z is equal to n equal to minus infinity to plus infinity del n minus 1 z to the power minus n. Now where this function will exist? Because of the shifted delta function. If you will know that if xt into del t minus t naught, then what should be the function value? X of t naught. We have described it in continuous time domain, a discrete time domain, Laplace transformation, Fourier transformation, that is Fourier series, Laplace, everywhere. Okay, and system description, everywhere we have described all these things about the properties of the shifted delta function. Okay, so as it is shifted delta function and it is situated at n is equal to 1, so the signal is also present at n is equal to 1. Other than n is equal to 1, that will be vanished. So that's why, as per the properties of the delta function, shifted delta function, we can easily write there z to the power minus n, it exists at n is equal to 1. So that is 1 upon z. That is z inverse. So if it is shifted delta function and delta function is shifted to the right side position, then the z transform of this shifted delta function will be 1 upon z. Correct. So x of z is equal to 1 upon z, or you can say z inverse as per your choice. So where it does not exist, it does not exist if z is equal to 0. That is 1 upon 0 is infinity. So that will not converge. So limiting factor is that ROC क्या होगा? Entire z plane any values of z, it will exist except z is equal to 0. If z is equal to 0, 1 upon 0 is infinity. So that is uh, undesirable. Okay. So that at that value of z, xz, they don't give you the finite value. Okay, that is that xz is not converging over there. Where it is not converging? If you take the value of z is equal to 0. So that's why ROC means the region where the z transform exists, xz converge. Okay, the value of xz converges. Okay, for each value of z. So entire z plane, you can take any values of z. For that, exist or it gives you finite value. But if you take z is equal to 0, in that case, it will not give you a finite value. So that's why I'm telling something like that. ROC of this shifted delta function is entire z plane, but we don't accept z is equal to 0. We can't take the value z is equal to 0. So this is for your right-sided shifting of delta function. In the same way, you can take del n plus 1. Okay. In the same way, you can take del n plus 1. So see, xn is equal to del n plus 1. So in that case, it will be shifted to the left side of the origin. That is n is equal to minus position. Somewhere there, maybe n is equal to minus 1. And that is your del n plus 1. So for that, what should be the z transform? We got it. Xz is equal to n into minus infinity to plus infinity. Del n plus 1 into z to the power minus 1. So that value will exist at n is equal to minus 1. And if you take minus 1, so z to the power plus 1. So z. So from this expression, by seeing this expression, we can conclude that it will exist entire z plane except z is equal to infinity. If you take z is equal to infinity, so x of z will be infinity. So that will not converge. So पहला क्या था? राइट साइड शिफ्ट ऑफ डेल्टा फंक्शन के लिए z is equal to 0 एक्सेप्ट था, और लेफ्ट साइड के लिए z is equal to infinity. So these are few basic transformation, okay, of different sequences, and these are basically standard form. So that's why you have to remember every time these standard form, okay, for betterment your. Otherwise, you will get some bad idea. So the thing is that a to the power n un minus a to the power n u minus n minus 1, xn is equal to u of n, xn is equal to del n, xn is equal to del n minus 1, xn is equal to del n plus 1. These are basic standard sequences. So for all these, you have to remember the ROCs and their corresponding Z transformation. Okay. I think you understood. Still, if you have having any trouble, you can tell me. Okay. So we can explain it once more. So after uh, uh, that, we go for properties of ROC. Okay. Properties of ROC. So no, there is one more sequence. So यहाँ पे देखो, वो जो पहला वाला जो शिफ्टेड डेल्टा फंक्शन था, वो दोनों एक साथ में है, del n plus 1 plus del n minus 1. Okay. So for you understood now, del n minus 1 के लिए except z is equal to 0 था, del n plus 1 के लिए एंटर z प्लेन था, but z is equal to infinity नहीं होना चाहिए. So for del n plus 1, what was the z transform z? Del n minus 1 का क्या था? Z inverse. So ये क्या होगा? If you take LCM, z square plus 1 by z. So now you have to include both the conditions. So ROC means entire z plane except z is equal to 0 and infinity. So it's a simple. So Keep all these things, okay, in your mind always. Now we'll go for ROC. What is ROC? What is the definition of ROC? Already I have told you, range of mod Z or R. Range of mod Z or R for which Z transform, that is x of Z. Z transform means x of Z of any signal xn or sequence, okay, converges. So xz should be converged, okay. That region, the value of xz converges. So that region basically is called ROC. So range of mod Z means the R. That is R is equal to 1, R is equal to 2, R is equal to 3, R is equal to 4. Whatever value be the R, in general R. So range of R, because here ROC in circle wise, okay. In the case of Z transform, ROC should be the circle, okay. Maybe inside, maybe outside, maybe between the two circles, all these things. So range of R for which Z transform of the signal xn, you can say x of Z, or equivalently, you can say that DTFT of the signal xn into r to the power minus n converges. चाहे x of z, you can say that, or you can say that equivalently DTFT of the signal xn into r to the power minus n converges. So where the value of xz converges, that region basically is called the region of convergence. The name suggests that region of convergence. So the region में जो value होगा within the region, within the circle or outside circle or the within the two circle, over there xz should be finite. That is the case. Xz का value finite होना चाहिए every time. So you have to find out that region, that place over which xz gives you the finite value. So that means it converges. It not go to the infinity. So that is your ROC. So we can start the properties one by one. So properties of the ROC. The first and foremost property is that ROC will be a circle centered origin in the Z plane. Already you know that whenever we are showing you the ROC, we are drawing a circle, keeping the origin at center every time. So whenever you are going to show a radius, may whatever be the radius may be 1, 2, 3, 4, 0.5, 0.6, whatever be the R1, R2, R3, A, B, C, D. Okay, don't bother about that. But the origin should be center of the circle. So this is your origin. Keep this origin at the center of the circle, and you have to draw as per your radius. Okay, depending on radius, it will extend. But at the center, origin must be there. So that is the first condition. Otherwise, other condition not be fulfilled. So first properties is most important, and your semester exam, so question may come, write down all the properties of the Z transform. It's a common question. It may come. So ROC will be a circle every time, just like your S plane in the Laplace transformation. There is a S plane, imaginary axis, y axis, and the x axis real axis. Plane tower. Like in this case, it's a circle. So ROC will be a circle, center origin in the Z plane. That is the first thing. So this is the real Z, this is imaginary Z, this is the circle, center at origin, and this radius may be R. The first properties. Now, the second properties. ROC do not contain any pole, like your Laplace transformation. Same is here. ROC do not contain any pole. ROC में pole नहीं होना चाहिए. Okay. So that is also second properties. Now the third properties. This is most important. Everyone is important, but you have to keep in mind all these things whenever you are calculating xz, because every time after calculation of xz you have to write the ROC. So until unless you understand the ROCs, you can write down. So if x of n is right sided sequence, just like your a to the power n u of n, isn't it? We have taken that right sided sequence as a to the power n u of n, as u of n is there, and left sided sequence क्या था? Minus a to the power n u of minus n minus 1. So if xn is right sided sequence, then ROC of xz will be outside the outermost pole. हम लोग देख चुके हैं. We have seen this ROC for a to the power n u of n mod z greater than a. Mod z greater than a. So that means the ROC is outside of the circle of radius greater than a. So in this way, if they are telling that, suppose you are having 3 poles, there is no single pole. मान लो you are having 3 poles. They are placed at 1, 2 and minus 1. So how to draw the circle? The thing is that I have told here xn is a RSS, that is right sided sequence. But you have to remember xn क्या है? वो right sided sequence है. ठीक है, लेफ्ट साइडेड नहीं है और डबल साइडेड भी नहीं है, only the right sided sequence. Then xz will be outside the outermost pole. So यहाँ पे outermost pole कौन है? -1, 1, 2 से 3, among 3 2 is the outermost pole. सबसे बाहर में क्या है? 2 पोजीशन में ये वाला पोल है. So circle should pass through this outermost pole. Okay, so in that way you have to find out the radius. यहाँ से 1 से you don't draw the circle with the 1 because 2 से ज्यादा है. So that's why the condition that xn is a right sided sequence. If xn is right sided sequence, some kind of a to the power n even some kind of that, then क्या होगा? ROC of xz will be outside of the outermost pole. जैसे तुम्हारा लेप्लास में क्या था? लेप्लास में क्या था राइट साइड सीक्वेंस के लिए? 3 poles are there. Okay, suppose -1, -2, sorry, -1, -2, -3. So right of the rightmost pole, है ना? Right of the rightmost pole. ठीक है? So that was the case in the case of Laplace transformation. और in this case क्या होगा? Outside the outermost pole. जैसे था ये right side of the rightmost pole, यहाँ पे outside of the outermost pole. ये outside तो होगा ही right side के लिए, तो किस पोल का outside होगा? ना outermost pole का outside होगा. So जितने सारे पोल होने दो, कोई प्रॉब्लम नहीं है, लेकिन you have to find out which one is the outermost pole. Okay, so ROC should be outside of that outermost pole. Okay, so that means the circle will must pass through that outermost pole. Then only the ROC should be outside of the outermost pole. मान लो यहाँ पे 3 था, suppose 1, 2, 3 है. So you have to draw the circle here so that 3 will pass through the circle. Then it will be okay, otherwise not. So if you have doubt regarding this, you can tell me the question. Okay, so that is the case here. So this is for your right sided sequence. The left side की क्या लेगा? Just opposite होगा. Okay. जैसे तुम्हारा यहाँ पे क्या हो? Inside the innermost pole. Inside the innermost pole. जैसे मान लो तुम्हारा क्या क्या है? -3 में है, -2 में है, and 1 पोजीशन में है. So origin से कौन सा नजदीक है? 1 नजदीक है. Origin, this is your origin center. So 1 is very closest. So this is the minimum distance होगा. So that's why you have to draw the circle here. इसलिए मैंने क्या बोला, if xn is a left sided sequence then ROC of its xz will be the region in z plane inside the innermost pole. So three poles are there, -3, -2 and -1. इसी में से innermost pole कौन है, that you have to find out. पहले क्या था, outermost pole कौन है, you have to find out. But in this case right left sided के लिए innermost pole कौन सा है, you have to find out. So in 3 में से -3 -2 1 में से 1 ही 0 से origin से पास होगा. ओके, सो इनरमोस्ट पोल कौन सा है ना, 1 है. इसलिए थ्रू 1 वी हैव ड्रॉन द सर्कल एंड इनसाइड दिस, तुम तो जानते हो लेफ्ट साइडेड के लिए इनसाइड द सर्कल आरओसी होता है, और राइट साइडेड के लिए क्या होता है, आउटसाइड होता है सर्कल के. ठीक है, सो दिस इज द केस. नाउ देखो यहाँ पे z इक्वल टू 0 अंदर में आ गया, z इक्वल टू 0. सो इफ xn इज एंटी कॉजल, ये क्या है, लेफ्ट साइडेड सीक्वेंस मींस ये एंटी कॉजल है, तुम बोल सकते हो. सो xn इज एंटी कॉजल, दैट इज if xn is equal to 0 for n greater than 0, this is the condition for anti causal, then ROC of xz will include z equal to 0. So z equal to 0 be included here as it is within this range. 0 z equal to 0 included here because inside the circle है. That's why for left sided sequence के लिए z equal to 0 भी होगा, z equal to 0 भी इंक्लूड होगा यहाँ पे. और राइट साइडेड के लिए क्या होगा, if xn is causal means xn is equal to 0 for n less than 0, this is the definition of causal system, then ROC xz will include z is equal to infinity point also, because ये कहाँ जा रहा है, infinity कब जा रहा है, for right sided sequence के लिए z is equal to infinity also be included here. So these two conditions, left sided sequence के लिए that is anti causal के लिए z equal to 0 इंक्लूड होना चाहिए, एंड causal के लिए और राइट साइडेड सीक्वेंस के लिए z equal to infinity इंक्लूड हो जाएगा. So that is your fourth number ROC properties, that is your fourth number properties. So राइट साइडेड हो गया, लेफ्ट साइडेड हो गया, ROC सर्कल होना चाहिए. ठीक है, ROC पोल नहीं कंटेन करते हैं. सो दीज आर द 4 बेसिक प्रॉपर्टीज ऑफ ROC. नाउ डबल साइडेड होगा तो क्या होगा, लेफ्ट साइडेड भी है राइट साइडेड भी है, तो क्या होगा, राइट साइडेड के लिए आउटसाइड और लेफ्ट साइडेड के लिए इनसाइड. सो ये स्ट्रीप हो जाएगा, इन बिटवीन होगा. देखिए जैसे तुम्हारा लैप्लास में क्या होता था, दिस इज for your this for your right side and this for your left side, so common area strip line, ये strip line होता है इस plane में. So similarly here also for the inner circle it should be for the right sided sequence, and for the outer side circle that should be for the left sided sequence. So left sided sequence के लिए अंदर और inner circle जो right sided के लिए outside. So कुल मिलाकर क्या कॉमन एरिया क्या है, दिस इज द कॉमन एरिया. सो दैट आई एम शोइंग दिस इज योर ROC फॉर लेफ्ट साइडेड सीक्वेंस एंड द राइट साइडेड सीक्वेंस. तो जब लेफ्ट साइडेड सीक्वेंस एंड द राइट साइडेड सीक्वेंस both are present, then this sort of ROC will come. If you have any doubt, you can ask me the question. These are most important. And in the coming semester, you will study DSP, digital signal processing. Over there also Z transform again will be there. Okay, then all these things you have to study once again. So right now, if you understood very carefully over there, you will get the you will be more beneficial. So यहाँ पे क्या देखा मैंने, ये आउटसाइड देखा राइट साइडेड के लिए और ये इनसाइड देखा. तो if these two are simultaneously present and this right sided के लेफ्ट साइड के लिए बाहर में होगा, राइट साइड this is बाहर में, so that will be region inside, and जो अंदर में जो सर्कल है उसके लिए बाहर होगा region of convergence. So कुल मिलाकर ये जो कॉमन एरिया है दिस इज लेफ्ट साइड के लिए अंदर, राइट साइड के लिए बाहर. So common area this is the common area. So this is your imaginary z, this is real z. Okay, so this is for your both sided sequence. Okay, both sided sequence के लिए. So for that I have taken one example here. B model. B model. So ये क्या है? Model means e minus n होगा plus n भी होगा. तो b to the power n un, this is your x1n you can consider, and minus के लिए क्या होगा? b to the power minus n, and this un क्या change हो जाएगा? e minus n minus 1. So this is for your left sided sequence. This is your right sided sequence. This is the sum of these two, x1 and x2. x1 के लिए हमको तो पता है a to the power n un. In the place of a we have written here b, nothing more than that. So we know x1z. Don't worry. Now find out x2z. So x2z क्या होगा? ये भी हम लोग थोड़ा बहुत कर चुके हैं. n is equal to -1 से -infinity जब -1 तक होगा, because u minus n minus 1. So u minus n minus 1 कहाँ तक एग्जिस्ट करोगे? -infinity से n is equal to -1 तक. So that's why it is a minus n minus 1. So लिमिट क्या होगा? -1 -infinity से -1 तक, b to the power minus n, j to the power minus n was the formula. Now n is equal to -1 to minus infinity to -1, bz whole to the power minus n. Now पहले हम लोग किए थे लेफ्ट साइड सीक्वेंस के लिए minus n is equal to m. Okay, let us assume minus n is equal to m. So when the value of n is minus n minus infinity, so m plus infinity हो जाएगा. If value of n is -1, so m का वैल्यू +1 हो जाएगा. यानी क्या हुआ? ये लिमिट थोड़ा चेंज हो गया. m is equal to -1 से प्लस इंफिनिटी तक हो गया. एंड bz होल टू द पावर माइनस n की जगह में हम क्या लिखेंगे? m लिखेंगे. सो bz टू द पावर m. नाउ यू सेपरेट दिस. That means you are putting the values of m here. When the value of m is equal to 1 here, it should be bz. m is equal to 2, bz square. m is equal to 3, bz cube. In that way you move on. Now take bz common. So if you take bz common, this should be 1, this should be bz, this should be bz square. Then the next term should be bz cube. So there is a series, there is a sequence. Okay, what is that? bz is बाहर में आ जाएगा, this bz, and that we can write down. This sequence we can write down in the summation for n is equal to 0 to infinity bz to the power n. So n is equal to 0 to infinity bz to the power n. So this is now formula. We know this. If summation is come, that sort of sequence, we know that in that case, if it is a, so 1 by 1 minus a. So that's why bz is there, and for this summation we can write down 1 by 1 minus bz. So ultimately क्या हो गया? bz by 1 minus bz. So that is for x2z. This is your left. This is your x2z. This is a z of the x2n. This part. Now these are in summation form. Okay, so that will come later. Now you have to find out the ROC for this. For this, you people know that ROC. Mod z should be greater than b. Mod z should be greater than b, or r should be greater than b. We know that the ROC of this sequence. So for that, we have to find out the ROC. So it is less than 1 minute. We will join again. Okay.